So let's continue. So the main takeaway from all this we talked about in the first part of the lecture about the C-type arrays, right, is that you have no restrictions, no protection against going out of bounds. So if you need something more complex, the advice is to use actually a vector or the standard library array. So there are actually other built-in arrays. This is like the what's underneath, but actually you don't really want to probably use this if you can avoid it, right? So in the midterm, I won't require you absolutely to use the array. You'll be able to use a vector if you want to avoid some of these errors. I mean, you can still use them, right? If you want, right? So, and again, so if you do want to initialize, right, you can use curly braces, right? If you don't, you have complete garbage, right? So, yeah, so this means 0, as soon as you have curly braces, right? We already talked about this, right? You have initialization, right? So partial initialization also works because your rest are zeros, right? So, so you cannot in a single unit, right? So if you want to do something, right, right, you cannot. It's not going to copy this. I don't think it's going to be illegal. It's actually pointed right. Well, we'll see about this, right? Let's try this idea, right? So to copy. So let's try copying an array. Let's make a. Let's create a blank array of size 5, right? Right? No values. Let's copy the first element's files, right? So basic idea is this is what you have to do by hand, right? And again, magic numbers, right? So again, I would say again const size t, right? R size 2, right? And this, of course, I will do it here, right? And of course, again, right? All right. So, yeah, so copying also is painful because, of course, you have physical memory. You have to do it one by one, right? Well, you could move also some arrays. There's no command such as like numpy. You cannot just do everything at all at once because, of course, underneath it's still doing it, right? Of course, compilers these days, right? Well, they're smarter than us, basically. When you compile, it's possible it can be vectorized underneath, actually, because CPUs these days support multiple instructions underneath, but you don't have to worry about this abstraction, right? It's actually what's happening, right? You do have to, if you have to copy, right, you have to copy it like this. Let's take a look. And let's see results. Let's print the new array. All right. Yeah. R4, right? And of course, this is not going to be anything great. Yeah, not surprising whatsoever. What else, right? Yeah, so arrays, how do we give them, so how do, we cannot pass arrays directly by value. So you have to give them reference space. So in effect, you're actually sending the memory address, actually, right? So, you don't have to use that symbol, right? So size is usually omitted, right? Right. So, right. So the problem is, of course, how do you know the size, right? Yeah. So this is really kind of. So let's make a function to print an array, right? So let's make a function to print a generic printing out function. We've been printing all this, printing it. How is this going to work? What do you think is going to happen? Well, let's take a look. Right. So this actually kind of gets really tricky. So now let's make a function. Let's make a function that prints all elements of an array. Right. Arrays are passed as references. As reference to function. Okay, so well, let's take a look.
Can you technically put it in a while loop, and when it points to null.
Well, but you're not guaranteed it's going to point to null, right? Because null is 0, right? Oh, if you point null pointer, yeah. But of course, the problem is you keep going, right? I mean, you'll be keep going. Eventually, right? You keep checking the next memory address, right? There's no like now. We'll see this. You'll see C-type strings. Yes, there's now, but when we go through the address, I mean, there's more memory, right? You're not at the very end, right? Because now it's special memory address, which is of course 0, right? Somewhere, right? But you're not gonna reach it, right?
But doesn't the last element point to the?
That's if you make a linked list or something, right? You can make something like that, but it's of course an array. No, it just keeps going. It just keeps going. So basically, these, right? So you basically, right? It's you have this big memory, right? And you took, right, 5, right? My array 2, size 5, and let's imagine that these are actually 4 bytes, 4 bytes, right? To make things 8 bytes, 8, 12, 20. 24, 1, 2, 3, 16, 20, right? So, right? There are no guardrails here, right? You just keep going here, right? So, again, if you want the guardrails, you use the C++, the more advanced structures, right? Then yes, you will have the guardrails. Right now, anything goes, right? They say, you know what you're doing. They know what you're doing, basically, right? So, again, let's take a look at this, right? I am curious. This is kind of interesting. Print, right? Let's see if this works, actually. This is kind of tricky, right? Will this actually work? I'm curious. Yes, and this is a very interesting point. I think AI is wrong. Well, not AI is wrong. I think this is not going to work. I don't think this is going to work, right? Typically, historically, you pass, and I don't like typically again coming from C language because remember there are differences, right? You do pass the size because there's no way of getting the size in regular plain C. This is very dangerous because you don't know. You don't know how many items you have. Let's take a look. I think this won't work. I don't think this will work, but maybe it works, right? Let's take a look, right? So, danger here. Do fix me. Is this safe? This safe, right? This is very, very suspicious to me. Well, check, right? Let's print this last array, right? So print. What do I call it? Print. What do I call it? Print array. It's a void function, R4. I hope, let's see what happens. Oh, yes. Where's okay? All right, and this is not gonna work. All right, there's a size of integer. Right, so this is not already. Right, and this is already not. You cannot trust AI on this, right? That's the thing. So, typically you would pass, you would calculate, right? So this is, right, we'll see about this, what the book says, right? Yeah, constant, right, you can pick, right. So size, right. Typically, yeah, so what we will do is, of course, array size t, array size. This would be the way to do it, right? You cannot do this. Typically, I'm going to double check, right? In C you cannot, right? Getting array size in C++, that was passed as reference. I don't think you can do it, but maybe I'm wrong. You see, it's a pointer. It's called pointer decay. And this is what really gets you. Maybe, right? Remember, this is just regular array, right? This is a question somebody asked, like, right? Yeah, it's called array decay, and you cannot do it, right? So you need to pass this. You need to pass it. So again, everybody says instead pass a vector, right? Because again, so this is one of those gotchas. This is again because underneath these primitive arrays, they are basically just a collection of memory addresses, basically pointers, right? So you need this, yes. So you need to safely use unit path size of, right? So this is again still true. It's still true. I don't know who answered this, but this guy, 10,000 looks okay, right? So this is 20,000. Yeah, again, looks legit. So to say, right? So again, but yeah, it is indeed. This has been the case for last, I don't know, forever, right? And it's not likely to change, right? Instead, you use the higher level structures, right? So you see again one of the reasons why this is so dangerous. So what we do here, of course, we would have to, right? Again, yeah. So to do so, we need to pass the size array, because array, yeah. So our size 2, we could do this, right? So this would work, of course. All right. And this now will work fine. So this was a case of hallucination. AI was wrong, right? So, okay. I think let's go to C. Yeah, we can use. Yeah, we can use, of course, this. We use the enums, but that's fine. But let's get to C. Yeah, selection sort. We saw in algorithms. Yeah, auto, right? You can use this new syntax, auto. So now we get to the C strings. Another good news is you should know they exist. Hopefully you won't have code you have to work with them, right? Because they are like arrays with the provision that the last character is a null termination, like terminator, right? They have null, right? 0, right? Special marker, sentinel value, right? Which says, okay, that's it. So, and these are pain to work with again, right? Many security bugs have been because of these character arrays, right? Because it's very easy to make a one-off error and overwrite this, null termination, right? There's even jokes about this, but to overwrite this and not keep and keep going. So let's see the C type strings, C strings. We call them C strings, right? So I'll make a new file. This one is getting kind of big, right? So our more passing array size, right? Okay. And now, hopefully I'm recording all this. Yeah, I am recording. That's good. And let's make C strings. I'll call them C strings. Yeah. So the last element is so. Yeah. If possible, use new. Yeah. All right. For now. Yeah, so let's start. Yeah. Okay. So you include IO stream, right? And using namespace, and we will use main. Yeah, so int main, right? So how do we define them, right? So my name, right? So I'll do car name equals, well, I can do this, yeah. So this equals, well, this, right? Right? This is the C string. So how many elements are in this string? How big is this? How many?
How big?
Yeah, length. I'm gonna get size of this. Yeah, I'm gonna get size. Because how many should be there? Let's get started. Well, no.
Also, someone because of.
Yes, now terminator. Because of terminator. Yeah. Let's get the size of this. Yeah. So. Yeah, okay. So So size the single car equals, of course, size of name 0, my first one, right? Size name, right? Number of cars, right? Let's take a look. It should be 7, right? Because it is actually part of the, it's basically an array. It's especially just a regular array we just learned in the first lecture, in this first session, right? Except it's using character type, right? So char, right? Char character, and it should work. Let's take a look. G++, we'll see about our errors, and C strings, and output C strings or whatever, right? And let's see what happens. Yes, indeed, like I said, size of singular is 1 byte, or 1 bytes, yeah, plural, right? Size of C string is 7 bytes. So everything clear on this, why, right? So you have a special terminator, right? Now again, so it is again kind of dangerous, right? Again, you have to worry about this, and again, I'm not going to even, I won't even cover these. You can use them, but again, since I'm not going to, the general advice is to avoid them, again, unless you are actually working on an old C. Again, remember, these are different languages, C and C++, they share pretty much like, 80-90% of the code, of the, abilities, maybe less now. But these are very dangerous functions, basically, right? Some are safe, some are not so safe, and some are actually, for example, string length. Actually, if I remember correctly, string length was actually was responsible for a GTA game, because string length is linear. To actually get the length of C string, you have to count the characters, right, each time, right? So it's not stored anywhere, right? There's no storage of the length, right? You have to do it every time, right? So it's I believe so. That's the case, right? So again, you can compare it, but I'm not going to even worry about this right now, right? So, right? So, yeah. So it's very painful, right? So again, my advice is not to use them if you can avoid it, right? Okay, but now we get to maybe two-dimensional strings, two-dimensional arrays, right? That's of course is again, so we can use multi, nested arrays. Well, two-dimensional. Let's do that actually. So again, advice again. So let's print this string, but so we could change the name, right? Name 0, right, by 1, right? Again, it's really painful, right? Do all this, right? W, right? Yeah. And again, 3 operations with C strings are quite painful, right? Primitive and painful, I would say. Painful. And prone to errors. P, right? Prone to errors, right? So, again, and you see, so I've written code on this. It's not fun, right? So, my advice is don't do it if you can avoid it. Of course, if you have some, old application which use these type of strings, and well, you see, since iOS, the string from C++ is C++ code base, you have access to better stuff, right? So you cannot do, changing separate values, right? You have to do it one by one, basically, because they are just primitive values, right? Okay, use advice, use, right? So we will, which we've been using, right? So that's why I won't ask you on this on the midterm. We have like 20 minutes. We have 10 minutes or we have 10 minutes. Let me introduce you to vector, which I think I like better, and also standard array, right? So we'll cover it more in some extra lectures, but I'll show you why I like it better. Basic C strings. This avoids most of the pain. We saw this pain. Now we get to vector. Vector or vectors. Vector. Right. Vector is C++. Yeah. Right. Vector is dynamic array. Size can be changed. Right. Very nice. Very useful. Very convenient. And this one, right? So you can have any type. So it's generic. It's template generic. Generic. Right. So vectors are safer, right? Vectors are iterable. Yeah. Vectors are, yeah. Right. Other things too. Right. Underneath, it is using, of course, using these C-style arrays we saw in, right? But let's have some fun. So include IOStream and include vector. Right. So this is this is what you should be using, right? If you need an array, well, okay. There is also a fixed style array, right? This is dynamic, but this is usually what you want. It's kind of very convenient, right? Depends how much you want to optimize your application, right? Right. Using anything, yeah, let's do it, right? Let's use it from main, right? In main, right? On numbers, vector of numbers, right? Empty vector of numbers. So all you have to do is you have to declare that this has it's in type, right?
The screen turned off.
Oh, good. But let's see. Let's kick it.
The other one works.
Yeah. So it's I think it's this one here somewhere. I think. Right? No? Or maybe here. Maybe here. Right.
Just turned off, I think, because too long.
Oh, it just let sleep, you think?
Yeah, I think so.
Yeah. Okay. All right. All right. There you go. No. So this would be empty vector. Right. Let's add some vector. Let's set some numbers. Yeah, exactly what I want to do. Push back, right? It has a method. So again, you use Python. Again, it's very kind of like append, similar to append in Python, right? Push back. There are other ones, of course, too, right? Push back, right? And of course, now, well, that's enough, right? Let's print the vector. And again, what do we use? Right. So this is. See now, you had your question, right? Jacobs, right? Jacobs. Yeah. You were saying about the size, right? This is what you have. The size vector does have size. So much more convenient, right? Less chance of making errors, right? Because the issue with the C-type array was that you have to store it separately, right? In some cases, right? You have to pass it along, like, and you have to remember, right? Here it comes with a sort of like a built-in, right? Somebody, well, hopefully there are no bugs, right? But it's, it's been going on for like 30 years almost, right? So it's pretty safe, right? Of course, sometimes small structures, you find some bugs, right? But yeah, and now of course it will should work quite nicely. Vector. Oh, okay, let's see. All right. And yes, of course, pretty simple, right? We can also initialize vector upon creation. But yeah, this also works, of course, right? So now it's interesting thing. Now we can print, of course. Now let's get size and also max size. Yeah, so that's one I mentioned this already. The vectors, since they are dynamic, they sort of get this max size vector. So max size can hold at the moment, right? It's not absolute top. So this is very cool. It's kind of cool, kind of cool thing. So let's take a look. Right? Max 7 more numbers. Let's take a look. Let's compile it, no problem. Oh, yes. Oh, yeah, I like this one. It seems like there's a little bit more than my memory. It's a little bit suspicious. Why is it that seems a little bit too? So 1, 2, 3, 4, 5. Okay. Apparently, yeah. So sometimes, yeah. You can specify this, right? So this time it's very lenient, right? So it's again, if you had like, it's not possible to have that much RAM, right? But yeah, it's pretty much, so in this case, it's not really important at all, right? But by default. But there are some cases where you can more specify this, right? And it's actually, in this case, it's actually not, not max reserve, capacity. Okay, sorry, capacity, that's the one, yeah. Okay, yeah, that's what I want to say, yeah. So this is actually, yeah, so this is completely fine. Also, we want capacity. Also we want capacity. That's also meaning what is current allocated size. So that's the thing, yeah. Capacity, current capacity, right? So usually you don't worry about this actually. Compile, yes, no problem. On yes, 5, right? Let's remove the last element. So what do you do? Pop back. What is pop element? If we talk about data structures, popping does what? It removes the element, right? Usually, yes. Notice something interesting here, right? This is different from Python lists. You see the help that says, you see the signature of this function? Inline void. So this means, that's all it does. It pops, it means it destroys the last element. It does not return it. That's different. So yeah. So there's actually, that's why it's mentioned. If you want it, you will lose it, right? You should first return it. So how would you get the last element? Well, let's get the last element. There are two ways. Of course, you can use size. Yeah, back. Pop back and back. So of course, we could use size or back method. I like back better. That's much more cleaner looking code, right? So of course, you use size -1, which of course is time tested, right? Works, but back is also nice. I like that because you don't have to worry about, okay, size -1, right? So you use, of course, if you want second before last, you use size -2, right? Okay. Yeah. Yeah. We could store it. Yeah. Unlike Python. Yeah, so this is they want to mention. Okay, now let's print the vector. And again, we will use auto. Yeah, we don't want to worry about it. I'm bored. Yeah, so this is, I like this again. And we do not care about index. Yeah. Right? So this is a short syntax, right? Auto, number, more numbers. Again, if you don't need the index, you don't need to use this, where is it? Here? Yeah, this approach, right? If you can, right? If you need the index, this is fine. If you don't need index, this is usually what you want, right? So, the new style, oh no, I messed up somewhere. Okay, yes, what is it? Oh yeah, it's just a warning. I'm not using last element. Okay, yeah, let's do that. Okay. CO, yeah. Now compile. Remember, I'm using compilation with any warnings are treated as all warnings, even some which are not maybe that important, right? So last element is 50, right? So pop back. So yeah, so I think this is much cleaner. Vectors are fun and easy to use, right? So this is what you want to check for all you can do with vectors. And again, we'll play around with it. This is like one of the main workhorse of our Yeah, indexes, of course. Docs. Yeah, there we go. There's also array. There is also an array, right? I think one that mentions here. Let's see, array, static size array C++. Before we finish. Yeah, C++ reference. There is one. STD array, right? It's a fixed size array, right? Again, underneath you have the same C type array again, of course, right? So this is what, again, if you need fixed size, you know for sure you're not going to change the size, right? Because there is some slight overhead, right? So of this, you use this instead. You could also use fixed size. You could also use fixed size version. Yeah. All right. But again, generally vectors are what you want. And also, so about capacity. So again, let's check capacity and size again. Capacity, right? Vector, yes. So you see this now. So size is 4, but capacity is 5. So again, what do you think? Okay, it's not something you should really worry too much. But usually, how is this memory allocation happening? What's happening? Do you know? Generally, it's usually powers of 2. I expect that you have 5i, it reserve 5. As you add more members, the capacity will start jumping. There's an algorithm for this, which will start jumping. Usually it's double or maybe log something. So meaning you have 8 items, you have 9th item, it will make room for 16 possibly, right? Why? Because allocation, making room for more memory is kind of expensive operation, right? You don't want to do this for every item, right? So you want to do it only every once in a while, right? Maybe every 16, okay, and then you add more. Expectation is that you will add more items, even more, right? So next time you double the capacity again, right? So say, okay, enough is going to be enough. So, and then the next time you add, so 32, 64, and so on. You keep adding more capacity, is the expectation, okay, finally, this guy is going to be stopped and it's going to be enough, right? So that's how the memory allocation works, actually, underneath. But again, we'll talk more about vectors in the future lectures. Again, this is like your main workhorse. The book talks about vectors much later. But I say practically, again, right? If you start working, you will want to use vectors, right? So we will also want, of course, two-dimensional, right? Vector of vectors, right? Possibly, or two-dimensional vector, right? Yeah, like 5 minutes. Let's finish that. So let's make a two-dimensional vector, right? What could be stored in two-dimensional vector? A grid, basically. I guess we could call, a multiplication table. I guess we'll do that. Let's make a two-dimensional vector that stores multiplication table. All right, of say 10 by 5, right? Make things like so vector in multiplication table, right? Right. So obviously now in this case you don't really have to worry too much, right? So now vector for I is 10, I is less than 10, right? Because there's the values, right? We don't have to worry about indexing, right? Of course, it's zero-based indexing, right? Of course, right? So we have row, we create the vector row, we push back, right? Row push back, right? And we put the row inside, right? So vector little. So this is a little bit tricky, right? And then, yeah, for auto, right? On table and end line, right? So we have a nice nifty multiplication table. Yeah, nice looking table. Looks pretty good, right? So of course, if you wanted the indexing, it'd be much more painful to do this with old-style C-type of vectors. Of course, the C arrays, right? How about? But I can show you this, right? So if we had to, let's do the same with C-type arrays in 2D, right? So something like this, right? Right? It's possible, right? But you have to worry about indexes, right? Quite a bit more. And now printed. Now printed. Right? Again, works, but you have to pay attention to this, right? Again, it will work. And of course, again, it's easy, right? With AI to, again, even if you have 0 by 1 error, right? Again, you will go off again. Right. So the one big difference is that try to get value which is outside the vector size. Okay, this should crash the program. Should. Right, more numbers. Let's see if this works. Should we crash? Or will, well, I don't know. Right, remember, we don't have 100 numbers, right? I think this should crash, right? And this is good. Bless you.
Thank you.
Yeah. Hopefully it crashes. It warns. It doesn't warn, unfortunately, if you are using Rust or Go or some other better, language, not I'll say better language, but more modern languages, you have some warnings. You're doing some bad stuff here. There's some tools, of course, for this, right? This should, it worked, actually, 0. So that I don't like that, actually, right? So it did work. It didn't crash. So AI is not to be trusted again, right? So, but it worked, right? But the thing is, what you do is instead we could use a method. Yes, I think is, well, that's one, of course, you could do that. But we can also, I think there was a method, special method, I forget now what it was called. Iterator, RBegin, MC maxize, fill, that was array, that's vector. There was a very interesting way to do it. At. I thought there was a one. You have to check. You do have to check still, right? You don't at. Okay, at. Yeah, that is at. So this is what the at. So we'll be finished and we can go get some food. Okay, here's the go. Okay, at. Yeah, this is what we should try, and this should give you an exception. We'll talk about exceptions separately, right? Compiles, and now it should. Yes, aborted, core down. Okay, so if you want this to happen, which is usually what you want, because it's extremely, it's better to, program crashes and burns than continues operating, right? So usually, actually, crashing and burning might be preferable to silent errors. Silent errors are the killer, right? And you write a banking application and you are suddenly, $5 million in debt, right? Right? So, yeah. It happens. All right. No. So, thank you, everyone. I'll see you.